Hey guys, very good morning. My name is Mithilesh Singh and today I'm going to talk about AWS Transit Gateway. In this session, we will understand what is AWS Transit Gateway, how does it work, how can we implement and how does AWS Transit Gateway reduce VPC peering complexity. So let's see what it is, and before moving ahead first, let's verify the current VPC peering complexity. So let's assume you have one VPC and you have deployed two virtual machine over there and you want to establish the connection. So it's a quite simple when you have a single VPC and you have deployed multiple virtual machine under same VPC, they all can communicate to each other without any problems because they will use the local network of this VPC. But if you have deployed one more VPC and you want to establish communication from VPC A to VPC B, then you cannot establish the communication. The reason why can you not establish the communication? Because the VPC is virtual isolated network. Okay, it does not allow to communicate any system from VPC A to the VPC B. The reason because there is no connection. And if you want to establish the connection, if you want to establish the communication, what you have to do is you have to set up a connection between them. And this connection is known as VPC peering. If you have two VPC, you have to create one VPC peering. And it is quite easy and simple to configure, but it becomes complex when you have multiple VPC in your environment. So let's assume you have four VPC in your environment and you want to establish connection from VPC A to all VPC. For that, what you have to do is you have to establish VPC peering from A to B, C, and D. So here you can see you have four VPC, and from VPC A you have established three connections to establish communication from A to B, C, and D. And in this scenario, you can see B cannot communicate to the C, and B cannot communicate to the D as well. To to establish the communication from B to D and C, what you have to do is you have to establish a VPC peering from here as well, from B to C and B to D plus C to D. So once you're done with this, so all your VPC can communicate to each other. But for this, how many connection you have created? So you have created total numbers of six connection here. Okay, numbers of six connections. How can you calculate the connections? How many connection you have created? So there is a formula on the top. You can see N is numbers of VPC, and then what you have to do, numbers of VPC is like here 4, and then numbers of VPC 4 minus 1 and divided by 2. So it is a 12 divided by 2. You can see you will have the exact number 6. If numbers of VPC is 5, then how many connection you have to create? So 5, 4, 20 divided by 2 is you have to establish 10 VPC pairing. So it increase by the time when you numbers of VPC increase in your environment and you want to establish the communication between all the VPC. So you can understand, right? This is a very repeated task and nobody like to do the repeated task and create the over administrative overhead. Okay. This is the communication between VPC. But if you want to establish or access your virtual machine from on premises, how can you do this? So there are two ways. Either you deploy your virtual machine over the public network, which is not advisable or recommended. You always advisable to deploy your virtual machine in private subnet. To access any virtual machine from the private subnet to your local environment or on premises, what you have to do is you have to establish a connection, VPN connection, or direct. You can use the direct connect. You can establish a connection from the on premises to your VPC. And in this case, there are four VPC. So how many connection you will establish from your on premises? So whatever the VPC, you have to establish the connection with each of the VPC. It means from the on premises, you have to establish numbers of four connections. From the on-premises to VPC, numbers of 4 connection, and within VPC you have created 6 VPC peering. So you can understand for the 4 VPC you have to maintain 10 link or 10 line, which is quite complex. So what we understand or learn from this topic, so VPC peering basically it's a complex network design. When it increase the numbers of connection as well, and it is a repeated task. Nobody like to do the repeated task. Also it create the administrative overhead, which is not good for the cloud administrator or any engineer. It's a quite time consuming task because you have to do this task again and again and nobody like it. Also you have to maintain or manage multiple link, which is also complex when there is a problem and you will have to do the troubleshooting. So let's see how AWS Transit Gateway will reduce all this problem. So in this scenario, you can see we have a Transit Gateway. What is Transit Gateway? Transit Gateway is a virtual router for your AWS environment. Okay. And what you have to do to establish connection from VPC A to the VPC B, you need not to create the peering between them. What you have to do is you have to create attachment from VPC A to the transit gateway and VPC B to the transit gateway. Okay. And if you have other VPC like VPC D and C, you just create a attachment with the transit gateway. And once you're done with the attachment, what happens? VPC-A is able to send the request to the transit gateway, and from the transit gateway, it can reach to the VPC-B, VPC-D, and VPC-C as well. If you have numbers of more VPC in your environment and you have done the attachment, then VPC-A can communicate all these three VPC as well. And same thing happen with all the VPC. They can communicate to each other. Okay. So you can see here. So numbers of 7 VPC, numbers of 7 connection. But in the VPC peering, you can assume, right, when you increase the numbers of VPC, it increase the multiple connection at the same time, which become very complex to maintain and to do the troubleshooting. But here it's a quite easy, quite simple to configure and manage the environment. Also, to establish the connection from on-premises, what you have to do is you have to establish a single link with your on-premises to the transit gateway. You need not to establish a VPN connection from your on-premises data center to the VPC as you did in our VPC peering or direct VPC connections. Okay, so it also reduce the numbers of on-premises connection or from client-side connection to your AWS environment. So let's see how can we configure the VPC. Let's see how can we configure the transit gateway and how will it work and how can we do the attachment or association from VPC to the transit gateway. So there is a brief description you can read from this slide. So this is demonstration part. So centralize TGW. First, what you have to do is you need 3 VPC. So VPC A, B, and C. You can take any name as per your use case. And I have just decided the CIDR block for the VPC A, B, and C. You can use the same for your demonstration purpose. And then create subnet as mentioned below. So guys, just follow the same instruction so that you will complete your lab. Okay. So on my console, if I go, I have already created the numbers of VPC. So I hope you all aware what is VPC and how can we create. If not, you can go and watch my video related to the VPC. It's quite simple and easy. I know you can do that. So here is the VPC A, B, and C I have created. And then the subnet it is talking, subnet is already I have created. I can open in different tab so that you can see the subnet. So here it is a subnet. Then next, what it is saying, in the subnet, I'll give the brief information. Okay. So from the VPC A and VPC A, I have created two subnet, in one for availability zone A and other for availability zone B. Why? It's for the high availability point of view. And same I did for the VPC B. And for the VPC C, I have created a bit different, right? I have created one public subnet under VPC C so that I can deploy a virtual machine over there and assign a public IP address so that I can access it and do the demonstration. Also, I have created two private subnet as well in the VPCC. Then what you have to do is next you have to create and attach an internet gateway to VPCC so that you can deploy a virtual machine into the public subnet under VPCC and can access from the internet. So let's see if VPC internet gateway is created or not. So let's go here. Okay, so internet gateway is created. I have given name VPCC IGW and it is associated with VPCC. You can see its ID is ending with 3BE. You can verify from this VPC 3BE. Okay, so internet gateway is also created. Create two new route table in VPCC for give it name like VPCC public RT and VPCC private RT. So let's see. I have already created that. It's quite easy. You can see it is created already. You can if you have not done or you are not aware, what you have to do is you have to click on create route table, give a name like VPCC public RT and then choose your VPC and then create it. It's quite easy to complete. So I have created about the VPC route table and then select VPCC subnet, public subnet and create a route table. So let's do that. So go on the VPCC public subnet, click on the route and create a route table. So it is already there. What I can do, I can create it again for you. I mention 000.2 internet gateway and attach your gateway. All right. So what is next? Add VPCC public subnet into VPCC public route table. So what I have to do is I have created a public subnet, VPC public subnet, this one. I have to attach this public subnet into my VPC public route table. So let's do the association. Click here, subnet association, edit, and search your VPCC public subnet. So here it is name. Click here and save it. This is done. What is next? Create TGW and give a name Hub Transit Gateway. So I have prepared these steps for you so that you will not miss any part and follow the instruction and do your practical part easily. So I have to create the transit gateway. It's quite easy. You can find it under the same console VPC. Here it is. Click on transit gateway and then click on transit gateway creation. Give a name hub TGW and in the configure the transit gateway there are multiple options. First is the ASN value. What is ASN value? Basically it needed when you are going to establish connection from transit gateway to the on premises, and currently I'm not going to do that. So but if you are going to do, you can assign a number over here. If you are not assigning any ASN number, it by default take 64512. And there are few other options which I will talk specifically. The first is this options default route table association. So what is this? So default route table association is basically when you do the attachment from one VPC A to the transit gateway, it automatically add that particular VPC into the transit gateway route table. Okay, and the next one is default route table propagation. So default route table propagation, what does it mean? So once you add the VPC, your VPC A into the attachment, so transit gateway automatically create a route table for your VPC. So we'll see in detail what it is and how does it work. If you want, you can disable this as well. We will see how can we disable and create it manually in our next video. So just leave all other options as it is and create transit gateway. Transit gateway creation will take some time. Okay, so let it be create. I'll pause the screen and then come back. Now it is available. So let's go on the next steps. Choose transit gateway attachment and create the attachment same as below. What is same as below? So it's talking about VPC A, B, and C. Okay, so let's do that. What you have to do is for the attachment, you have to go into your transit gateway attachment and click on create transit gateway attachment. But before this, I want to show one thing. So it is transit gateway route table. So once you done with the transit gateway creation, it automatically create a route table for you. The reason why it create automatically because you have selected these two options. Okay, default association and default propagation. You can assign a name before moving ahead. So it is a TGW RT. Okay, let's go to the attachment. And the moment, right, I'll go back again one more time. The moment you attach any VPC with your transit gateway, the transit gateway automatically associate or add that attachment under the association, propagation, and it also create the route table for it. So let's see, first do the attachment and then we will understand what it is. Click on create attachment, select your transit gateway, and attachment type will be your VPC. There are other options available. We will talk later in our next session. And then assign a name. So VPC A. So I'll follow the exactly same name what I have given here. Attachment. I'll copy this name for our next use. And then select your VPC A. So once you select your VPC A, it selects some subnet. Okay. So why will it select some subnet during the attachment? So if you go back to our slide here, so you can see there are four VPC, right? So when you do the attachment with the transit gateway, how transit gateway will communicate to your VPC? Okay. So while doing the attachment, transit gateway requires some IP addresses, right? On the subnet. So what you have to do, you have to give subnet from your VPC so that transit gateway can take or create a network interface card into your network. And behalf of that network interface card and the IP address, it will communicate with your VPC A. And same thing happened with other VPC as well. So let's do one thing. Let's erase it. Go back to our screen here and you can select your. So I have selected two, from one from availability zone A and other from the availability zone B, so that if AZ1A goes down, it will be accessible from AZ1B. So it is creating. Till the time it is create, let's verify the route table. As I said, once you're done with the attachment, it create the association. So the attachment is still going on, so it will take some time. So till the time it is creating it, let's create the other two. The same process you have to follow. VPC, assign a name B, select your VPC B and the subnet, create it, and do the same for your VPC C. In the VPCC, make sure you are not selecting the public subnet. Okay. So under VPCC, I have created one public subnet. We should not deploy our transit gateway under public subnet. Okay. For the security reasons. So I'll select private and create it. So it takes some time to complete the creation. VPC A is available now. Let's go into the route table. Click on the association. You can see VPC A is associated with your transit gateway route table. And the same time, it also added into the propagation. Okay. So here it is showing 2. It means 2 VPC are associated. So it also add into the propagation, and the moment you add into the propagation, it dynamically create a route table for you. So let's verify, refresh it and see whether the third is attached or not. It is attached now. Okay, what is next step to do? So we have done with the attachment. The next option is once you're done with the attachment, all attachment will get associated. Yes, it's done. Go into VPC route and rename the default VPC as a VPC A RT and VPC B RT, which I have already done. But let's double check it before going ahead. So click on the route table and you can see I have already done this two part. Create a new route 000 and point it to TGW in both VPC A and VPC B plus into the both VPC C. So VPCC has two route, public and private. So let's start from the VPC A. Click on the route table. Click on the edit, add route, and then 0. Select the transit gateway. And same thing too with the VPCB. Create it. Go into your VPCC private. Click on edit route table. And under VPCC, so you cannot use the same route 000 to TGW because you are pointing it to internet gateway. So leave it as this, create another route and use 10.0.0/8 because all your subnet or CIDR belong to this particular. If you go here, all three CIDR belong to 10.0.0/8. So it's good if we add this one and point it to the transit gateway. So we have done with the routing. Let's go back to the screen again. Here, okay. So on the VPC, right? So let's take the VPC A. What we have done, we have under VPC A route table. What we have done, we have said if there is any request apart from this local CIDR, send it to the transit gateway. So from it, it will send to the transit gateway. And what is transit gateway route? Transit gateway route is TGWRT. Okay. And under TGWRT, it reaches to the TGW. Okay. The connection will reach to the TGW. And the moment it reaches to the TGW, TGW will verify it's on route table. And the route table name is TGWRT. What does your transit gateway will do? It send the traffic to the TGW RT. It's on route table and see and it will say, let's verify the request. Request is coming from the subnet or VPC A, okay, and it is trying to communicate with VPC B, let's suppose, okay. So what happened? So it the moment it reaches to this, so first it will verify the association, whether the transit like attachment VPC A is attached or it is associated with TGW route table or not. So under this, it will identify the VPC with the attachment ID. Okay, and then what it will do? It go jump into the route table. It will say what is your requirement. So the request is coming from 10.0.0.0.16, and it want to go to the 10.1.0.0.16. So what it will do? It come here and then it will follow to the transit gateway route table route. It will send this request of VPC A request to the 10.1.0.0/16, which is the your VPC B attachment, and it will send the request to the VPC B attachment. And same thing happened with other VPC as well. This is how your transit gateway will route the traffic. So let's see how does it work. Okay, so the next part is what I have to do is I have to create three virtual machine to complete this demonstration or uh, establish the connections for like ping or remote desktop connection. So first create a virtual machine under VPCC into public subnet and assign a name Bastion host. So I'm going to create a virtual machine. Click here and launch new instance. Select on free, choose your Windows server, any server you can choose. I'll prefer to use the Windows server and use your free tier instance type. So VPCC and the public, I selected the public and enable the auto assign public IP address. Next, assign a name. Next to configure security group if there is. So I have a already a security group. Port 3389 is allowed for everyone. It's okay. And now review and launch it. What is next? So next is create other virtual machine under VPC-A. Give the name VPC-A VM. So let's do that. Do not assign auto public IP address. Let's say if any, yeah, there is also a SG. I have already created this before. Click on this and create one more under VPC B. So let's do the same exercise again. So all virtual machine are deploying. It's in initialize state. So I'll pause the screen and come back once it is done. So let's do one thing. Let's first connect the Bastion host and click on the Bastion host. Pick the public IP address of it and to the MSTSC. I can log in on it. So let's take the IP address of VPC B VM. It has the private IP address. So let's copy and paste under VPC B. Paste it here. So let's go on the virtual machine, what you have deployed in public subnet in VPC C. Try to access the virtual machine which is in different subnets. So Here you can see we are able to establish a successful connection from VPC A to the VPC B and VPC C. So this is the password. I'll put the password here and access the connections. So you can see on this small box, it is the virtual machine of VPC A, and in the back side you can see our main screen. That is our virtual machine, which is under VPCC in public subnet. So from VPCC virtual machine, I have access the VM which is in under VPC A. So you can see, right? We are able to successfully establish the connection from VPC A, VPCC to VPC A, and if you want to check whether you are able to connect VPC B system from the VPC C or not, let's do the same thing. Or you can do one thing. You can no need to take the remote desktop. You can also do the testing. Open the PowerShell. Meanwhile, it is opening. I'll open it in the other system as well. So from VPCC, let me minimize this one first. From my VPCC, I'll try to test net connection. Port 389, which I have opened, and then computer name I will give to the system IP address, which is under VPC B. You can see it is a successful true. It means VPCC system is able to communicate or connect to VPC B. And same thing happen if I try from the VPC A system. So let's copy the same command from here and double click, maximize it. You can see it is also true. So guys, this is what or how can you configure your transit gateway, and how can you establish the communication or connection from one VPC to other VPC, and you can reduce the numbers of VPC peering. Okay, so there is one more testing, so let's do that as well. So this is our, let's close this one. So this is our main VPCC virtual machine, which is in internet subnet. So from here, if I try to access the internet, you can see it is accessible. But when I try to access internet from the virtual machine which is under VPC A, so let's see. Google.com. You can see it is taking time to access the internet from your VPC A. Okay. The reason why it is not able to connect to the internet, because there is no internet connection from VPC A or VPC B to the internet. Okay. So in the next session, we will understand how can we like to establish the internet connection from your VPC A and VPC B. Okay. For that, as you know, we have to create the NAT gateway. So earlier, when we were not using the transit gateway, we create the NAT gateway under each VPC. Okay. And we will reduce the numbers of NAT gateway. We will not create the NAT gateway under any of the VPC. We will make one VPC as our outgoing. Will follow this standard. So for your knowledge, we'll create, this will be our VPC A and B. Take an example, and this is our transit gateway. And we will create another VPC here, which will be as a egress VPC. Okay. So what we will do, we will create the virtual machine under private subnet under here. You will be able to access from your on premises. Okay, and this VPC will be able to communicate with this VPC with the help of transit gateway. And when it try to access the internet, what happen? It will send the request to transit gateway, and transit gateway will send the request to your egress VPC. And from here, it will be one, or you can say one gate to send the traffic outside your organization. So guys, that's all for today, and I'll make the other video what I talked right now and post it soon. Thanks for watching.